Hello everyone. You have seen a very interesting experiment last time, that was reaction of acids with metals. Now I have another experiment, that is the reaction of acids with metal carbonates. Now, or even metal bicarbonates. Before we start, I have again few questions. Have you ever tried ENO? It is an antacid. Now what we do is we take a beaker with water and we pour that ENO or antacid powder inside the water. And immediately you will see lot of fizzing, lot of bubbles, lot of gas release and all. And people drink it. The reason they drink it is when they feel too heavy, or when the acid is excess in their stomach, they feel a little bit of disturbance in their esophagus. So they drink this to neutralize any acid that is excess in their stomach or the throat. So what does an antacid has? Antacid has a little bit of acid and a little bit of metal carbonate like magnesium carbonate or some other carbonates. So it's a mixture of both of those in dry form. Since it is dry, like powdered form, they don't react. But as soon as you pour them in water, they react with each other and they create a gas. That gas is the crucial part of this experiment. Now let me give you one more example. Now why do cakes puff out? They bulge out when you actually add baking soda into that particular cake mixture. So in that there is a reaction between an acid and the baking soda. It's a carbonate, metal hydrogen carbonate. When these react, again a gas is released and that gas is responsible for making the cakes very fluffy. Same thing with our rice cakes. We call them idli in Telangana and Andhra, right? So even those, they become fluffy during the fermentation process. So all of these are related to reaction of acids with metal carbonates. Now let's write few details about this experiment. Again we are using dilute hydrochloric acid and this time we are taking calcium carbonate, CaCO3. This is nothing but marble powder. The eggshells that we have, the eggs, the outer layer is the eggshell. That powdered form we can call it as calcium carbonate. When we react both of them, some sort of gas is created. That is what we are going to explore. After completing the experiment, we'll try to fill up this particular section. But for now, let's go ahead and start with the experiment. Here are the materials required for the experiment. I'm using a conical flask. You can also use a boiling tube or a test tube. Then I have again a matchbox and an incense stick to test the nature of the gas. We use something similar to see the hydrogen gas. Then I have my hydrochloric acid, 3 molar, and then I have carbonate. This is calcium carbonate. Once we complete this particular experiment, the next thing that I am going to do is I will pass the gas from this particular conical flask into lime water. Lime water is nothing but calcium hydroxide solution, CaOH twice. This is lime water, it is colorless. We will see if there is any change in color when we pass the gas. So shall we try this out? First what I'll do is I'll take a spatula. This is the spatula. And I will add calcium carbonate powder into my conical flask. And then I will add our dilute hydrochloric acid. Before adding dilute hydrochloric acid, I want to light my matchbox and the agarbatti, the incense stick. Thing is, whenever you are using flame, always put plastic gloves or rubber gloves away. When the flame, when the plastic catches fire, it would burn away your skin that is underneath it. Now please observe, I am pouring the hydrochloric acid. Please observe, that's immense fizzing, lot of fizz. And now I am placing this agarbatti at the top, and as you can see, it got completely put off. You can still see a little bit of red color but after it getting put off, I'm lighting it one more time, please see. We know that this flame is getting put off. That means the gas that is coming out will not blast anything. So now I'm going to place it even inside. And when I place it inside, you can see it's immediately getting put off. That means the property of this gas is to put off the flame. Can you tell me which gas does this putting off the flame? The gas that puts off the flame, the one that is very, very familiar to us, is carbon dioxide gas. In fact, carbon dioxide gas is coming out of this particular conical flask. And check out any fire extinguisher that is near to your school or in your school or somewhere at apartment buildings or shopping complex. Good quality fire extinguishers use carbon dioxide gas. In fact, they'll keep high pressure carbon dioxide gas. But some fire extinguisher might also use a mixture of high pressure air with sand. So please read the fire extinguisher contents. You might see carbon dioxide in that. Now let's go ahead and do the next part of the experiment. I want to start fresh, and for that fresh part, I will first pour away this liquid and then I'll continue with it. So I'm pouring away this entire mixture here. I don't need it anymore. I want to start fresh. So I'm adding fresh calcium carbonate in here. Now the idea is to pour our acid in there. But you have already seen the experiment. As soon as I pour the acid, enormous amount of gas is escaping into the atmosphere. So how can I transfer this gas into our lime water solution? We want to prove in a scientific way that the gas that is released here is carbon dioxide. So that is the reason what we have is, we have this assembly. Please see this. This is a double-holed rubber cork. 2 holes. In one hole, we have this thistle funnel. It's called a thistle funnel. It has this funnel portion, and at the bottom we have a long pipe. The advantage of this is this end of the pipe could go way deep into the test tube or the conical flask. And at the second end, I have a delivery tube and a rubber pipe attached to it. So the advantage of using this thistle funnel is I can place this pipe inside the conical flask. Inside the test tube with lime water, and here now I can pour acid in this directly. When I pour acid in this directly, the reaction would happen and the gas would release from this pipe. You might be wondering, will there be any gas coming from the thistle funnel? Yes, there will definitely be some gas coming from the thistle funnel, but since the funnel is very, very deep into the conical flask, little gas would come out. If I keep the stem of this thistle funnel way upwards, then most of the gas would also come from this thistle funnel, which would be a problem because we are pouring acid in it. Now, for additional ease of doing the experiment, I'm also placing a funnel on top of it. Now I'll pour acid. Please observe the color of this lime water. Right now it is colorless. I'm pouring small quantities of acid in there. And you can see a lot of bubbling action happening over there. And I want to observe the changes in color. I'm pouring little bit of acid at the time. Right, I think we did good. We can clearly see a color change. I can continue doing this, but let's look at lime water. I'm removing the pipe carefully. So kids, when they are doing this experiment, they have to use a tray because there might be spillage, and I don't want any chemicals to fall on their body or the clothes or anything. So please look at this. Lime water is turning to milk white color. This proves that the gas that came out of this conical flask during the experiment is carbon dioxide. And another observation is, if I touch this particular end, it's actually cold. The coldness indicates it is endothermic reaction. Okay, the previous experiment with hydrochloric acid was exothermic. Here it is endothermic. That means this beaker is taking heat from my body. My body or my hand is becoming colder. That's what is endothermic. Endothermic reactions absorb energy. Exothermic reactions push out energy, exit energy. So with that we are done with the experiment. I hope you understood the results. Now let's discuss everything on the board. Now let's look at the reaction. We have definitely seen carbon dioxide gas. We tried two proofs. One is a basic proof of flame retardation or putting off the flame. We already proved it. Then more scientific proof is lime water turning to milk white color. So that is the main proof. Anyway, calcium carbonate with HCl gives carbon dioxide gas, and also please think about the remaining products of this reaction. So we can obtain calcium chloride CaCl2 because calcium and chlorine they are reacting. In a way, this is a double displacement reaction. 7th class kids might not know, but calcium and hydrogen are exchanging their places. Calcium comes towards chlorine, so that's why calcium chloride is formed. When hydrogen comes towards carbonate, we actually create something called H2CO3. It's very simple. Calcium is coming to hydrogen's place. That's why we got calcium chloride. When hydrogen occupies calcium's place, we get H2CO3. This is called carbonic acid. Very, very unstable. It divides into water and carbon dioxide gas. So the third product in this experiment is H2O, CO2, and the last one is calcium chloride. Right, that is the entire experiment. Okay, and let's make it simple by writing it in words. For 10th class you can use these equations format, but for 6th class or 7th class the reaction is acid reacts with metal carbonate to produce carbon dioxide gas plus water and calcium chloride together is salt solution. Calcium chloride is a salt. This is water. Together we call it salt solution. So that is the entire experiment. Now I hope you understood why our fermented foods puff out. The reason is carbon dioxide. Why bakery products puff out, they kind of bulge out. It's also because of carbon dioxide. And also the reason why eno or antacid is added to water, you see lot of bubbles coming out. That fizz that you see is actually carbon dioxide. Okay. With that we are closing this activity, and let's meet again for neutralization experiment.